For number 2, part A, the topic here is irreducible quadratic factor. From the expression that you see the 4 terms of the denominator. The power, the top, the highest power is 2, the highest power is 3 for the denominator. The first check is good because this is already a proper fraction, so you do not have to do the long division. Now, we're going to factor the denominator completely. To factor the denominator, so I'm going to write on the side here, 3x to the third minus x to the second plus 3x minus 1. You have 4 terms. When you factor, we're going to consider like grouping technique. So the group the first 2, group the last 2, and then factor completely for each group. The first group, you have the common factor x squared, and then x squared multiplied by 3x minus 1, plus I put the coefficient 1 for the second group. So then I can see the common factor 3x minus 1. If we pull out the common factor 3x minus 1, the leftover of the first term is x squared. Leftover of the second term is 1. Okay. Now I have another form of the denominator in the factor of x squared plus 1 and the 3x minus 1. So I'm going to bring it back into the main part of the problem. Integral x squared plus x minus 2 all divided by, I'm going to write the linear in the front and then the quadratic in the back. Okay. So what do I mean by linear? The linear is the first factor here because the power of the x is 1 and the second factor is called quadratic because the power is 2. Okay. For the linear power 1. And what is the power of each term? The power of each term, the first one, the power 1, the second power 1. So the power 1 means you just need only one factor. So only one factor or one fraction, both of them, when you do the decomposition. All right. From this, the first one is a linear. You're going to have one partial fraction divided by that linear factor. The second one is the quadratic, x squared plus 1. Okay, now we're going to decompose into 2 pieces. The first one, linear. The linear, the numerator has to be 1 power less than the denominator. The denominator has a power 1. The top has to be the constant. So I'm going to put the a as a constant term for the numerator of the first fraction. And then the second term is a quadratic. The numerator has to be in the linear form or 1 power less than the power of the denominator. So I'm going to put bx plus c. I'm using the ABC instead of A1, B1, A1, A2, A3, and so forth. Okay, just make it like distinguished from each other. It's quadratic. That's why the numerator has to be in the linear form. So this is the tricky part. So we're gonna decompose the original fraction into the 2 pieces. And the next step, we're gonna find the value A, B, and C. So I go to another slide. Okay, oops. So right now, what we have, so I'm gonna write it as the integral x squared plus x minus 2 divided by the fraction denominator as the 3x minus 1 times x squared plus 1 and decompose to be something on top of the 3x minus 1 plus the linear terms divided by the quadratic term of the denominator. So this process, we're gonna find A, B, and C. Okay, to find A, B, and C, this is my prep work again. And similar technique, I mean the same technique basically, just you have to deal with different expression. The left hand side is x squared plus x minus 2 divided by 3x minus 1 times x squared plus 1, where the right hand side is the sum of these 2 fractions So I work on combining these two fractions by using the common denominator. That means my first one, I'm gonna multiply by x squared plus 1. And my second, I'm gonna multiply by 3x minus 1, 3x minus 1 to make the same denominator. So a multiplied by x squared plus 1 plus the quantity bx plus c times 3x minus 1 equals x squared plus x minus 2 divided by 3x minus 1 times x squared plus 1. All right, then I'm gonna work on equating the numerator on the left and numerator on the right. So this step, we equate the numerator. I have 3 unknowns. I'm gonna pick 3 numbers. Okay, pick 3 numbers. So still in the prep work area, okay? To find A, B, and C are 3 unknowns. I pick 3 different numbers. The first one, um, you can pick any convenient numbers like x equals 1 over 3, but it's kind of not quite convenient, right? Whatever number that you pick, it doesn't matter. So I pick 1 over 3 because if I pick 1 over 3, I can eliminate the second group of the product here. So if my x equals 1 over 3, the left hand side gonna be 1 over 3 to the second power plus 1 over 3 minus 2 equals a times 1 over 3 squared plus 1. And then the bx plus 3 plus c will be gone because 1 over 3 times 3 is 1 minus 1 becomes 0. So work on the algebra here. We have 1 over 9 plus 1 over 3 minus 2 equals, this is a times 1 over 9 plus 1, which is 10 over 9. And then clean up the left hand side, common denominator 9, 1 plus 3 minus 18. That becomes negative 14 over 10 over 9 equals 10 over 9 times A. So my A is negative 14 over 10 or negative 7 over 5. That's one number. Okay. And then I pick another convenient number. My favorite number is x equals 0. If I use x equals 0, I will get the left hand side 0 plus 0 minus 2 equals a times 0 plus 1, which is a. B times 0 is 0, going to be plus c times 0 minus 1, so going to be minus c. So I have negative 2 equals, what is my a? A is negative 7 over 5 from here, and then minus c, or c equals, I just rewrite it in a quick way. So c equals 3 over 5. And you can work on your algebra if you need more detail. I have my A, I have my C. Next, I'm gonna find my B. I'm gonna squeeze in the room here and use different color to minimize the confusion. I'm gonna pick another convenient number. My other convenient number, easy to compute, recall. So for this one, if I let x be 1, I'm going to have 1 square plus 1 minus 2 equals a times 1 plus 1, which is 2a, and then plus b times 1 plus c, or the quantity b plus c, times 3 times 1 minus 1, which is 2. Okay, I already have a as negative 7 over 5. I have c as 3 over 5. So then I work on algebra. So the left hand side is 0. And this one is negative 14 over 5 plus 2 times b plus 3 over 5. Okay, you clean up the number. And we're gonna get b equals 4 over 5. 4 over 5. All right. So the numbers we have a as negative 7 over 5, c as 3 over 5, and the b is 4 over 5. It's tedious, right? So I'll show you real quick what software or what web-based um, decomposer that you can use when you work on the problem when I finish this one, okay? So now we have the integral in the form of, let me see the original problem real quick. Um, right now, the integral x squared plus x minus 2 divided by original 1, okay? 3x squared, 3x to the third minus x squared plus 3x minus 1 dx decomposed into the integral. The a is negative 7 over 5 divided by quantity 3x minus 1 plus the b, which is 4 over 5 times x minus plus c, which is 3 over 5, all divided by the quadratic factor, which is x squared plus 1 with respect to x. It doesn't look pretty, but it can be done. The first one, we're gonna let you be 3x minus 1. So du is 3dx. So when you replace the first one with the u, we're going to get 1 over 3 multiplied by the coefficient negative 7 over 5 multiplied by natural log of the 3x minus 1. Okay, you can work on the detail later if you want to see more, more steps on that. And then the second term, we have um, the term is 4 over 5x plus 3 over 5. So I will break it up into two integral. So the first one is 4 over 5 integral x over x squared plus 1 with respect to x. The second one is 3 over 5 integral 1 over x squared plus 1 with respect to x. Okay. And then the second term here, I let u be x squared plus 1. So my du is 2dx. Now I have why I simplify the first term to be negative 7 over 15, natural log absolute value 3x minus 1. And the second term, oops, where did it go? So the second term will becomes 4 over 5 times 1 over 2, natural log of absolute value x squared plus 1. But the last term, this is if you don't recall the antiderivative rule for 1 over x squared plus 1, you're going to have to use the trig sub technique, which is very tedious. Okay, trig sub is too much work, but if you have the formula sheet handy, this one is the inverse tangent of the x, and then we're going to add c at the end. Clean up one more time. We have the solution as negative 7 over 15, natural log absolute value 3x plus minus 1 plus 2 and 4 reduce becomes 2 over 5, natural log absolute value x squared plus 1, and then plus 3 over 5, the inverse tangent of the x plus c.